Hey guys, welcome to this video. Today I want to show you one of the extra credit problems. I'm going to give you 1% extra credit if you can solve it. If you're one of my students, no matter what class you're taking, please go ahead, try to solve it if you want to. And come to me, we'll discuss your solution. If you're not one of my students and just watching that by randomly watching this video, then you can go ahead, take it, try to solve this, send me an email. It'll be in the description. And I'll let you know if it's right or wrong. Okay. So here's the problem for today. As you know, a function is called some kind of procedure, right? Which maps anything from the domain to anything in the region, okay? Domain and region can be sets of anything. It can be set of numbers, natural numbers. It can be irrational numbers. Can be sets of chairs. Can be sets of sets. Can be sets of functions. Okay, so there's kind of very, very vague and huge, broad definition of a function. And domain and region. But anyway. So, if we pick something in that domain X, right, then if we follow some kind of procedure applied to that X, that's going to give us something else which is called Y, right? And that Y comes from the region, okay? So I hope you already know that. Since I'm not a mathematician, I may not know the exact definitions. But anyway, so you have some kind of function, you provide something to this function, it spits out something different, right? And the function is kind of following some kind of procedure. So let's say your domain is basically a set of all sequences of all natural numbers, okay, of size n. Well, n can vary, okay. Those natural numbers, well, first of the natural. Secondly, if they're natural, technically it should mean that they're also zero, but I think it really depends on definition. But anyway, so we'll consider that none of those numbers can be zero, and so they are in a non-decreasing order. For example, if you have 1, 2, 3, okay, so that is a sequence of numbers in a non-decreasing order. They're all natural. And here's what the function is going to do. Okay, so if you're going to provide the sequence 1, 2, 3 to this function, what it's going to do is going to create another set of numbers which will be all possible summations of these numbers. Okay, so for example, for 1, 2, 3, what do we have? First off, if we sum 1, 2, and nothing, we'll get 1. If we sum 2 and nothing, we'll get 2. If we sum 3 and nothing, we'll get 3. And then if we sum up 1 and 2, we'll get 3. If we sum up 1 and 3, we'll get 4. If we sum up 2 and 3, we'll get 5. And if we sum up 1, 2, and 3, we'll get 6. Okay, so all possible summations of these numbers. Okay, I think it's called a power set, maybe. I don't know. So set of all subsets. Anyway, so you write out that set, and if you remove all the duplicates, for example, here we have 2 3s. Okay, so that's 1 3, and if I add 1 and 2, I'll get the second 3. So I need to remove this 1. I'm going to remove this 3 because technically a set should contain no duplicates. Okay, but anyway, so that is the result, right? So what you need to do, you need to find X. Or prove that X doesn't exist, or prove that such X doesn't exist, for which this is going to be the output set. Okay, 9, 11, 13, 17, 18, 20, 22, 24, 26, 28, 29, 30, 34, 37, 39, 41, 42, 50. Okay, so again, you have some kind of sequence of numbers. Okay, they may be the same, they may have duplicates, it's possible, but there are definitely no duplicates on the right side. You're given some sequence of numbers x, okay? You find all the summations of all the numbers in that x, and here's the result, okay? And you need to find that x, or you need to prove that such x doesn't exist. Yeah, that's it. So if you find that, or you prove it doesn't exist, I'll give you 1% extra credit. Yeah. Hope you guys enjoyed this. I'll see you next time. Bye-bye.